Okay, welcome back. Now we are going to look at the last part. The last part of the question is to find the value of IL at 0.1 millisecond. So we have to look into the transient response of this particular circuit. All right. Well, how do we look at this circuit? Basically, it's a RLC in series. Now, you may be tempted to think of, okay, maybe I'm going to use the Laplace transform. A Laplace transform for the current source is not as easy as you may think, because if you remember, IS is 10 U minus t minus 20 ut. So we don't really know what is the Laplace transform of u minus t. Now, fortunately, what we can gather from this circuit is that if you just look at the RLC in series, if you only look at this RLC circuit in series, alpha, which is the damping coefficient, is 20 ohm divided by 2L. That gives you 10 to the 4th. And omega 0, which is 1 over square root of L and C, you can evaluate this, is also 10 to the 4th. So this is a critically damped system. Okay? Now we may know nothing about this circuit, but we know that the response of the circuit is going to be something that looks like this. IL is going to be minus 20, because this is the ultimate current that's running through this. Okay, plus e to the minus 10 to the 4th t times A1t times plus A2. So we know that this is going to be the ultimate response, no matter what the coefficients A1 and A2 really are. All right. So what we have to do is to evaluate this, because we know that IL at T0 plus, okay, we know what that current is equals to 10 amp. Okay, so we know that minus 20 plus t equal to 0, e to the minus 0 times A2 has to be equal to 10. Therefore, A2 has to be equal to 30. All right. So the second thing we can do is to look at VL. VL is equal to L times di dt. And in this case, it's going to take the minus 20 out because it's a constant. So we're going to have L equals to 10 to the minus 3 times A2 e minus 10 to the 4t times minus 10 to the fourth plus a1 e to the minus 4 t plus a1t times minus 10 to the fourth times e to the minus 10 to the fourth t. It looks like a mess, all right? But basically, you're going to evaluate VL at 0 plus. Well, we do know what the voltage at VC is, and we do know what is the voltage at VR. Okay, so VL at 0 plus actually is going to be equal to 0 volt. So from here, we're going to find out that A1 is actually equal to 10 to the fourth times A2. In any case, we know that this is going to be the IL minus 20 This is what the IL would eventually look like. So IL at T